Today we're covering section 12.3, least common multiple of polynomials. These are going to be the steps that we use to solve or find our least common multiple. And we're going to look at it in terms of counting numbers, but also in terms of polynomials. So we'll start with the steps for finding the least common multiple of a set of counting numbers. The very first thing you're going to do is find the prime factorization of each number. Then the second step is to list the prime factors that appear in any one of the prime factorizations. And then the third and final step is to find the product of these primes using each prime the most number of times it appears in any one of the prime factorizations. Don't worry, we will go through this, some examples. The process for finding the least common multiple, or LCM, of a set of polynomials is very similar. Once again, you're going to completely factor each polynomial, including prime factors for numerical factors. Then you're going to form the product of all factors that appear, using each factor the most number of times it appears in any one polynomial. I have gone into the practice for this particular section. We're going to work through some problems. So section 12.3, here's our very first problem in the practice section. The first step was to find the prime factorization for each of our integers. So those were the factor trees. 4 is 2 times 2. I'm going to list all of the prime factorizations out. That's part of the steps. I'm going to list those over here to the side. 9 is 3 times 3. And remember, when you're doing prime factorization, you do the factor tree until you have prime numbers all at the end of your branches. For 6, we've got 2 times 3. I've listed out each of the prime factorizations. 4's was 2 times 2. 9's prime factorization was 3 times 3. 6's prime factorization was 2 times 3. And the third step said find the product of these primes using each prime the most number of times it appears in any one of the prime factorizations. So the prime numbers we have in this problem, we have a 2, and it appears the most with the 4, so it appears twice. And we have a 3, and it appears twice with 9. So I'm going to multiply all of these things together. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So the least common multiple of 4, 9, and 6 is 36. Essentially, what you're doing when you're finding your least common multiple is you're finding the smallest number or polynomial, when we get to those, that every number will divide evenly into. So the smallest number that 4, 9, and 6 will divide evenly into. That's your least common multiple. And the reason we're doing this is because we're going to do some problems later where knowing your least common multiple is going to help you simplify those. So this section just gives us practice with that. I will come in here and I will type in 36. Now I'll go in here and clear my annotations, and we'll start the next problem. We begin by factoring each of those numbers with our factor trees. 18, 2 times 9, 3 times 3. 18's prime factorization is 2 times 3 times 3. 24, we have 2 times 12, 2 times 6, 2 times 3. 24's prime factorization is 2 times 2 times 2 times 3. 3 is already a prime number. Now we go through, we find out what our factors are, and then we count up and use the most number of times it appears in any one of the prime factorizations. If I look at 2's first, I have 1 2 in the prime factorization of 18. I have 3 2's in the prime factorization of 24, so I'm going to use the one that has the most. So I'll be using the 3 2's from 24. When I look at the 3's, I have 2 3's with 18 in the prime factorization, 1 3 with the 24, 1 3 with 3. I'm going to use the most, so I'm going to use the 2 from 18. Now I just multiply these all together. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. 72 is going to be the smallest number that 18, 24, and 3 will divide evenly into. Now it's asking us, and this is one of the reasons that we want to know what our least common multiple is, it's asking us to compute the sum and simplify your answer. So notice here we have two fractions that we're adding together. And when you add fractions or you subtract fractions, you have to have a common denominator. This particular example already has a common denominator of 19, but if it doesn't, then I need to find my lowest common denominator, which is my least common multiple. Now, what this one has is nice because it already has the 19 there. So I simply add the numerators. 4 plus 4 is 8. I do need to reduce if I can. I don't think that reduces. So my answer is going to be 8 over 19. Clear my drawings again. I'm going to move my keyboard a little closer. I've got it kind of far away tonight. Find the missing numerator that will make the rational expression equivalent. Find the missing numerator that will make the rational expressions equivalent. Seven in the denominator on the left. I have a 2x plus 7 in the denominator on the right. It looks like on the right-hand side, I'm multiplying the denominator times 6 in order to multiply something and not change what my result is. Remember, I have to multiply by 1, which means I have to multiply my numerator and my denominator times the same number. So I took 6 times 2x plus 7 here. So in order to not change this number, I'm going to have to take 6 times my numerator. So 6 times 8 is going to be 48. Let's run through this one more time. My expression is 8 over 2x plus 7 equals question mark over 6 times 2x plus 7. Again, I look for the commonality. Both of those have a 2x plus 7 in the denominator. On the right-hand side, I'm multiplying the denominator times 6. So if I want these expressions to be equivalent, I need to multiply my numerator times 6, which means I'm taking 6 times 8 So the missing numerator is 48. And here is our next problem. Once again, find the missing numerator that will make the rational expressions equivalent. Find the commonalities. So when you're looking at it, you're looking for what's in common. On the left-hand side, I have y plus 9 over y squared plus 7. And that is equal to something I don't know, so question mark over y squared plus 7 times y minus 9. So they both have a y squared plus 7 in common. The fraction on the right, I have multiplied my denominator times y minus 9. So for these expressions to be equivalent, I've had to take my numerator, which is y plus 9, and multiply it times y minus 9. And I believe that it will accept it in that form. When I come down here to type that in, I don't think I actually have to multiply that out. I think I can type in y plus 9 times y minus 9. And I was correct. Another one, similar to the last one, find the missing numerator that will make the rational expressions equivalent. In this problem, I have 2 over 3 times the quantity x minus 9. I'll say that again, 2 over 3 times the quantity x minus 9, and that is equal to question mark over 6 times the quantity x minus 9 times the quantity x plus 9. So I'm going to identify what I have in common again, and I have an x minus 9 on the left and an x minus 9 on the right in my denominator. I have a 3 in the denominator on my left. I have a 6 in the denominator on the right. So I'm missing a 2 with that 6 and the x plus 9. So the pieces that are missing on the right-hand side in the denominator is a 2 and an x plus 9. So I'm going to take my numerator, which is 2, and I'm going to multiply that times 2 times the quantity x plus 9, which gives me 4 times the quantity x plus 9. Here's my next one. This time I'm finding the least common multiple, or LCM, of the polynomials. And I have z squared minus 5z plus 6 as one of my polynomials. And I have z squared minus 6z plus 8 as my other polynomial. In order to figure out what my factors are and find the ones they have in common, I actually am going to have to factor each one of these trinomials. So I'll start with z squared minus 5z plus 6. I'm looking for two factors of 6 that when I add them together give me a negative 5. So that will be a negative 2 and a negative 3. So when I factor z squared minus 5z plus 6, I end up with z minus 2 times z minus 3. And then if I factor the other trinomial, which is z squared minus 6z plus 8. I am looking for two factors of 8 that when I add them together give me a negative 6. So that will be a negative 4 and a negative 2. So z squared minus 6z plus 8 factors into z minus 4 times z minus 2. And it's a little bit weird. I'm just going to call it polynomial number 1 and polynomial number 2, but we're going to go ahead and list out the factors similar to what we did when we had the integers. So z minus 2, z minus 3 for polynomial number 1. Polynomial number 2 had z minus 4 times z minus 2. There are three different factors here. I have a z minus 2 in common for both of them, but remember we still use that factor the most number of times it happens. Well, it only happens once on each one. So z minus 2 is one of my factors, z minus 3 is my other factor, and z minus 4 is my third factor. So I have three factors here as my least common multiple of the polynomials that I was given. And that is the quantity z minus 2 times the quantity z minus 3 times the quantity z minus 4. Type that in the box, z minus 2 times z minus 3 times z minus 4. And I'm correct. Again, I love that green bar. Our next problem, we're back to adding together two fractions. So I have 2 over 4 plus 4 over 14. So I need the least common multiple between 4 and 14. So do the factor tree for 4, I have 2 times 2. Factor tree for 14, 2 times 7. So 4 is 2 times 2. 14 is 2 times 7. I have two number 2's in my first prime factorization, so I'm going to use both of those, and I have 1, 7. So 2 times 2 is 4. 4 times 7 is 28. That's my lowest common denominator, which is my least common multiple. So I'm going to rewrite these two fractions so that they're both over 28. 4 times 7 gives me 28. So if I take 4 times 7 in the denominator, I have to take 2 times 7 in the numerator. So that becomes 14 over 28. 14 times 2 gives me 28 with my second fraction. So I have to take the numerator times 2. 4 times 2 is 8. Now that my denominators are the same, I have 14 over 28 plus 8 over 28, and I will simply add the two numerators together. 14 plus 8 is 22 over 28, and I will reduce that. 2 goes into both of those. That's 11 over 9, not 19. It's 28, not 38. 11 over 14. Green bar. Example number 9 is find the least common multiple of the polynomials y squared minus 36 and 5y plus 30. We will start by factoring y squared minus 36. That's a difference of squares. So that factors into y plus 6 times y minus 6. Then we will factor 5y plus 30. This looks like just going to have a greatest common factor of 5. When I'm take out the 5, I'm left with y plus 6. So when I list out my factors for polynomial number 1, I had y plus 6 times y minus 6. For polynomial number 2, I had 5 times y plus 6. So I have a 5 times y plus 6 and y minus 6. That's going to be my least common multiple. 5 times y plus 6 times y minus 6. Two more examples. Once again, find the least common multiple of the polynomials. In this case, we have z squared minus 5z plus 6 and z squared minus 9z plus 14. So we will start by factoring z squared minus 5z plus 6. Two factors of 6 that when I add them together, let's start that one over. Z squared minus 5z plus 6. I'm looking for two factors that when I multiply them together give me 6. When I add them together give me negative 5. So that's going to be z minus 3, z minus 2. And when I factor z squared minus 9z plus 14, I'm looking for two factors that when I multiply them together, they give me 14. When I add them together, they give me negative 9. So that will be negative 7 and negative 2. Listing the factors for polynomial number 1, I have z minus 3 times z minus 2. For polynomial number 2, I have z minus 7 times z minus 2. So they each have z minus 2 as one factor. And then I also have a z minus 3 with polynomial number 1 and a z minus 7 with polynomial number 2. Z minus 2 times z minus 3 times z minus 7. Getting ready to do our very last example. This time we're going to compute the sum and simplify our answer. So once again, we have to find a common denominator because we are trying to add together 1/6 plus 1/10 plus 7/12. Prime factorization for 6 is 2 times 3. Prime factorization for 10 is 2 times 5. Prime factorization for 12 is 2 times 6, 2 times 3. So 2 times 2 times 3. The 2's appear twice with 12, so I count both of those. I have a 3 and a 5. 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. That will be my lowest common denominator. So I'm going to rewrite each of these fractions as something over 60. And I'm going to have to move it over. Someday I'm going to figure out how much space I have up here. Not sure when that's going to be. Try this again. I'll try it over here on the left. I know we're used to putting the equal sign on the right, but we can do either side. So again, each one of those fractions is going to be rewritten as something over 60. I had to take 6 times 10 to get 60, so I will take 1 times 10. So the first fraction will become 10 over 60. I have to take 10 times 6, so I have to take 1 times 6. So we'll have 6 over 60. I have to take 12 times 5. So I will have to take 7 times 5, which will become 35 over 60. So here we have 10 plus 6 is 16 plus 35 is 51. And I believe that will reduce, if I have 51 over 60, I think 3 goes into both of those. Yeah, 3 goes into 51 17 times, excuse me. And 3 will go into 60 20 times. So this reduces to 17 over 20. This concludes section 12.3. There are notes posted in Canvas, similar to the ones that I showed you at the beginning of this lecture. So if you want to go back and look at those steps, you are welcome to go back and look at those steps. Remember, if you are struggling or if you have questions, reach out to me. Also, as you go through the practice, if there's a problem you don't get correct the first time, go back and do as many problems as you want. If this problem stumped me, I can just come down here to the bottom and click try similar, and it gives me a new problem with similar instructions or similar problems and numbers. The other thing I want to show you today in this video is that if you are struggling with a particular problem as you're going through the practice, if you look down here at the bottom, and maybe, no, I want to go at the bottom. I don't quite understand why it doesn't like me to have the whole screen. But at the bottom, you have that send to instructor feature. And so you can do, if you hit send to instructor, it sends a screenshot of that problem to me. So if you get stuck on something, send me a problem and I will do a short little video for you. Thank you all for joining, and I hope you feel like you know a little bit more about section 12.3, and I will get ready to do the next video.